Bonjour. Good morning. Welcome, everyone. Good morning, Paris. Good morning, wherever you come from. It's such an honor. It's a great honor for me to kick off the first in-person JupyterCon since the end of the world. It's also a bit special for me because it's the first time that we do it in my home country. And it's a great vote of confidence for the local community, and also I'm grateful to the Jupyter leadership for their confidence in us and in our ability to organize this event. So thanks to them.
For our first keynote of the conference, we bring you not one, but two excellent GitHubbers. You might have some concern that they're each going to run in their own threads. Don't worry, they're going to use cooperative scheduling and talk sequentially, at least I hope. A little bird also told me that they might give you a demo, and so you may want to get your laptop out and sign into the Wi-Fi and connect to GitHub. So Craig Peters is a staff product manager at GitHub, focused on coding, on making coding accessible through developer tools. Thanks to Craig that we can enjoy Jupyter Notebook, GitHub Codespace, and GitHub Codespace. Craig enjoys cycling, cooking, and hiking with family, and it was the one with a corgi in his picture. It's a corgi, right? Yeah. Yes. And he also spent a few hours helping us print badges yesterday. And he will be joined by Cory Gwin. Cory is a senior software engineer at GitHub who believes in websites that get out of the way of users and makes tasks simple to complete. That's thanks to Cory that we can have rich notebook diff in GitHub UI. So please welcome Craig Peters and Cory Gwin. Thank you.
Thank you, Matthias, Sylvian, Maria, everyone for joining us, and we're really appreciative of the opportunity to share what we're working on and learn from all of you in the community. We're here to share what we're working on to show how all of us together can create such amazing new experiences by combining the platform that is GitHub for collaboration with the amazing technologies that Jupyter pulls together to enable us all to learn, grow, experiment, and become better with data. And our world is now data-driven, and so we really think that it's incredibly important that we're all able to do that. So our talk today is really around the various phases of doing that. Cory.
Yeah, so there's really three phases to working on any piece of software. The first one is discovery. GitHub is really good for discovery. We have a lot of tools around.
Jonathan, sorry, are we hearing this mic? Can we?
Hello? Can you hear me? Can people hear me?
Now we got it.
Hi. All right, could you hear me before? So let's start over. All right, cool. So we're really going to talk about the three phases of collaboration and how they happen on GitHub. So we've been thinking a lot about this, and we have some tools, but we wanted to make it better. So on GitHub, there's about 2.8 million notebooks, which is a lot. You can find just about anything that you would want. And then once you find something, there's this experimentation phase, which has never really been available on GitHub in the past. And then past that, you actually have to collaborate with someone. And collaboration has always been not so great on GitHub also. So we wanted to think over the last year, like, how do we improve this story and make this whole experience better from finding something to creating a pull request. And today we're going to take a look at a lot of the tools that we've been working on at GitHub to enable this experience. But first, who are we?
I'm Craig. So as Matthias introduced me, I'm a product manager. What that means is that I work with our engineers to create amazing experiences like the one we're going to show. Matthias credited me somehow with enabling Jupyter Notebooks in code spaces, which we'll look at. That definitely was not me. That was a fantastic team of engineers. My job was to help the engineers understand how people work, what problems they face. And with Jupyter Notebooks and these kinds of experiences, we're actually quite new. And so what I'm hoping out of this week is to learn from all of you about what you do with notebooks, what things that we have here that might spark ideas. I really think it's just a beginning, and I want to understand how we move forward. My passion at GitHub is working with open source communities in particular. I work with various parts of the Python community, Kubernetes and Go communities, more with the communities around JavaScript, TypeScript, and NPM. And my job is really to superpower open source folks on GitHub. Personally, I'm a pretty adventurous person. I love all kinds of adventures. My family is up there. We're at a waterfall in California where I live, hiking. And they don't enjoy the bicycle as much as I do, but I'm a huge cyclist, and that's where I spend my non-working, non-family time. I'd really love to speak to everyone and hear about what you're trying to accomplish. Cory.
Yeah, I'm Cory. I've been at GitHub for about a little over 6 years now, and I've worked on most things as a software engineer. Most recently, I've been working on our notebook infrastructure for different sorts of rendering experiences. And I got introduced to IPython notebooks way back in, I think, like 2016, 2015, something like that, working with a group of scientists. So when I came to GitHub, I've always been very passionate about open source and a contributor, sorry, to open source projects. And I saw an opportunity to try to improve the Jupyter Notebook workflows at GitHub, and eventually got myself into an opportunity to do that. So I'm excited to be here today to share with all of you what we've been working on. Personally, I love to bike, cook, and we are on a mission to find the best pastry in Paris. So if you know it and you know where it is, please let me know.
And one more item. Not only is this Cory's first time in Paris, let's all welcome him to Paris, but it's also his birthday. Happy birthday.
Thank you. This is a pretty cool way to spend a birthday.
So,
all right. So let's talk about discovery of notebooks on GitHub. As I alluded to earlier, there's a lot, in the millions. But it's not always clear like how you find them. So I just wanted to point you to a couple of cool features that we have that might help you find interesting notebooks. We have trending/Jupyter-notebooks, which shows the trending notebooks on GitHub. And then we have a topics, which is more of a curated list of Jupyter notebooks. And then if you're in a repo or an org or just searching across GitHub, you can use this path:**.ipymb, and it will find any notebook on whatever you're searching on, and you can use it that way.
So topics are actually community-generated content, so I encourage you to go to the topics and contribute interesting notebooks to help other members of the community find them.
Yes. Cool. All right. We see a lot of notebook views on GitHub. This is what we see in a week, 4 million. And you can kind of see how that goes in a day. And 92% of those are open source. So thank you for doing so much open source. We really love that. And 8% of them are private. And last year, we spent our time rewriting the rendering engine so that we could display more types of notebooks. We actually see quite a few as old as 2.0. And we see a lot of different sizes of notebooks, from very small to very big. And we wanted to make more notebooks reliable. Also, we had a lot of invalid notebooks, like lots and lots of invalid notebooks. And so we spent some time contributing back to NB-convert and NB format some of the more common invalid notebooks that we saw, and also made sure that you all get notices when you put up invalid notebooks and we can't render them, so that you know that that's happening. All right. We have a lot of different languages, too. Here's the languages of notebooks that we see in a week. That's just a mind-boggling number of languages for notebooks to be running in. I like to explore lots of notebooks on GitHub. I like to just jump into them and see what's going on. but I can't install all these things on my machine. Who has all of these languages installed on their machine?
Not me.
No, nobody. But like one of the great things about GitHub is there's just so much variety and depth and breadth. So we want to talk to you about making this better.
Thank you. So now that you've found a really amazing notebook, what do you do next? So you want to maybe contribute to it, or you just want to explore it and learn it. Once you've found it, it's time to sort of download all of those, the repository, do a clone to your local machine, figure out how you install all of the tools, get them up and running in your virtual environment or Conda, whatever tool you use for that, and to figure out what all of the dependencies are, and hopefully not end up pulling your hair out and being frustrated. Well, what if you could skip all of that and get right to work, even on an iPad or any kind of small device that doesn't have any computing power? What if I could say you could do that, and we could provide that for free to people all around the world, so people who don't have access to these amazing machines? What if a doctor or a clinician or a scientist in Rwanda or Central India could take advantage of this to contribute to all of the kind of learning and discovery that we're all doing? Well, we asked ourselves that, and we figured out that we could automate all of that setup and make that, reduce the cognitive burden that we all have trying to learn something new and make new discoveries, and distract us from the real creative work that we're trying to do. So we figured out we could automate that for development. In fact, we now build GitHub. Cory is one of the engineers who helps build GitHub. He actually works on Copilot now. He's worked on pull requests and rendering and all kinds of things. He's even worked on code spaces, which is amazing. And all of that work today happens in the code spaces product, which we're going to show you. But we also asked, well, who are other kinds of folks who don't think of themselves as programmers, who want to solve the same problem, who want to instantly get to working on things? And the way we do that is through this product that we've introduced recently called Code Spaces. It's cloud-based development environments that use a configuration as code model for allowing a maintainer, somebody to take a project, define a development experience and environment that then everyone can take advantage of. And that way, everybody who's coming to that project can have the same environment. You get rid of that problem, it works on my machine, why are you having trouble and it not working on your machine? Then if you combine that with the power of containers for reproducibility and packaging all of your dependencies, version control, all of that just becomes a real natural way of working in a repository and with your colleagues. And we'll show the sort of how you do collaboration around that. One of the key problems that I'm focused on is helping open source communities build their community. So I don't know if you've faced it. So how many of you are actually maintainers of open source projects? Like responsible for finding, that's a good number of you, thank you. How many of you are tired? Exhausted? Okay, a significant number. So that's exactly what we find in open source communities, that maintainers are really exhausted. And one of the big problems we find is that you all are struggling to get enough people contributing to the project that you can spread the responsibility out to more maintainers. And a big challenge there is just the sheer number of new contributors is not enough. It's not a big enough funnel of people to be learning the project and becoming familiar with the way it works. And so what we find in a lot of our work is that communities who implement these code spaces configurations can quickly make a better experience for new contributors, which makes it more likely that they'll create a second pull request, a second contribution. Thus, the third becomes more common, and they more quickly and more happily move up that contribution ladder. So I'm really looking forward to sharing that. So what we see is we bring the power of code spaces together with Jupyter. And the nice thing is that the tool chain that Jupyter uses is very common to a lot of open source projects. So we didn't have to do a ton of work to make it work well with Jupyter. What we needed to do was add native support for Jupyter to code spaces to make the process of creating the Jupyter server and supporting the ports and all of that a natural thing. We've now done that, and I'm looking forward to showing you a demo of that. But that tool chain is very rich, and we built a sort of a default experience so that when you go to any open source repository on GitHub and start code spaces, even if it doesn't have the configuration that we're going to dig into in a few minutes to make a kind of a tailored custom environment, you'll have a good experience because we pre-install a large set of tools that many of your projects depend on. We want to hear about which ones it doesn't that you also want. We also have technical limitations like everything else. There's a certain size of the number of dependencies that we can build into the default experience, but you can always add additional capabilities for your specific project. But all of this comes sort of out of the box with the default environment. In the demo I'm going to do in a few minutes, it's also using AstroPi and some other things that specifically for astronomy kind of applications. We're going to take a look at some data from the James Webb Space Telescope. Cory's wearing one of their t-shirts, which is super cool. So let's take a look at that. Let's take a demo. So there's a QR code in case you want to get to the demo. All of the demo materials that I'm going to show are actually in this repository that QR code takes you to, so you can always do this after the fact as well. So the first demo here is, I'll just tell a quick story about it. 2 weeks ago, I went to a talk at the local astronomy club where I live in California, and there was a very nice man who was a professor at a local university who does modeling. His job is to build models that explain the physical phenomena that are observed from the James Webb Space Telescope. In this particular talk, he was showing a model of how two binary stars rotating around each other very rapidly, and they're very large, powerful binary stars, binary star system, emit this very cool kind of concentric pattern we'll see in a minute that turns out is dust. And the confusing thing was that dust could exist. These are very strong, bright stars, and the natural thing to happen to that dust in the environment of all the high energy solar wind is to ionize that dust. And so his model was to explain why this pattern appeared. So that's just a little background about the demo itself. So let's take a look at that. Oh, come on, where's my mouse? There it is. So we have it recorded because conference networks are fun. So basically, the repository kind of walks you through just the high-level information about what it is to use Jupyter Lab and code spaces. You can start code spaces in many different ways. So if you click on the code dropdown, you'll see the normal clone features, but there's also a button which allows you to create a code space directly from that dropdown. I'm going to switch my default editor using the preferences to Jupyter Lab. So we now support not only Visual Studio Code and their web and JetBrains, but also Jupyter Lab as a native client. This is a beta feature today in code spaces. So once I've done that, I can click on the Open in GitHub Codespaces badge. It'll ask me if I already have an existing code space, it'll ask if I want to connect to that. And if I don't and I want to create a new one, it starts one up. And what it's doing is in the cloud, it's downloading that configuration, which we'll look at in a minute, making sure all the dependencies are satisfied for the particular project, and then launches the Jupyter Lab server, connects me to the client. So in the browser, I'm just connecting to Jupyter Lab. I've got my notebook, and I'm going to run all the cells. And I don't have to download anything. I don't have to install anything. It runs through the data processing pipeline that the researchers handed me for the sample notebook. I don't know how all of that stuff works. And voila, we've got this very nice image of the concentric rings of the gas that the James Webb Space Telescope observed. So let's dig quickly into how all of that works. So I described some of it while it worked, but the idea is on the left-hand side here, you've got your researchers, your programmers, folks who are working, you're collaborating with on your research or your data processing pipelines, whatever it is. And then there's kind of a certain person who's usually responsible for making sure that everyone who's collaborating together has the best experience. Like sometimes that's a volunteer among the researchers who has some expertise. Sometimes there's actually somebody who's called a maintainer. But they're the ones who are responsible for configuring the repository. So with code spaces, that maintainer creates a configuration that's in this file called the devcontainer.json. Cory will dig into some details of that in a few minutes. But that devcontainer.json is stored in the repository, so it's version controlled along with the rest of the code and any of the data. The code being notebooks, any other processing pipelines you might have. And then Codespaces reads that configuration when you launch it and does a whole bunch of work for you to make sure that you automatically and securely are connected to that environment with the IDE you want. The awesome thing is, if you want a different IDE, you can also connect it. So you might have Jupyter Lab as your default, but sometimes you want to connect to it with VS Code and use the VS Code extension for Jupyter Lab. Or there's many other ways in which to work with these things. You can just run the Jupyter server on the command line and then connect to it over the exposed port. And we'll take a look at that in a minute as well. So, Cory, can you tell us a little bit about the dev container configuration?
Sure. So here you see kind of a simple dev container. They can get very complex. But this one kind of shows some of the high-level things that you have. And it may look a little familiar because it's really kind of inspired and uses under the hood Docker. So what we have here is we have a name, which is basically the name of your code space. And then you have an image. So this is a Docker image, and this is your base image. Here we're using Universal 2, which is our base image that came with all the things that we showed you earlier. And then we're going to do some things to extend it. So the first thing that we do is we say, OK, we want to run this on a computer with 4 CPUs. So you can define many different attributes about what size computer should this run on. And then after that, we have some bash scripts. Here we're doing simple inline bash scripts. You can also put them in a separate file, what have you, to extend this image to include things that you need. Here we do a pretty common thing, which is install a requirements file. But you can do any sort of complex setup that you need. Maybe you have to call out to an external database. I work on one that automatically connects to a Cosmos DB instance running in Azure and runs migrations, that sort of thing. And there's a couple of different prefixes there: on, create, update, content. So those are lifecycle hooks, basically. So when a code space is created, there's different life cycles. Some of them run back in the background, can be set up to run in the background in an action. And that happens not during when a user would experience it, but runs prior to a user getting into a container, so things are pre-set up. And other ones you can have run when a user connects. So for example, we have a welcome message to introduce you to this container, tell you about it, and give you some information when you connect. We can also put in different plugins and things like that.
Sorry, just in the interest of time, I'm moving us
OK,
forward.
we're moving on. All right, next up is collaboration. So you have a notebook, you're working on it, and you're stuck, and you're like, oh my god, what do I do? Well, with GitHub code spaces, one really cool thing that you can do is you can collaborate really well. And this is an experience we've been trying to work on because, after all, we're GitHub, and collaboration should be something we care about. So here we're going to start our Jupyter Notebook in a different way. We're going to start it in VS Code. I actually always work with VS Code open. This is just my workflow. But I can start Jupyter Lab from the command line of VS Code running in the browser, which it doesn't have to run in the browser. You could also be running it locally. This is going to open up Jupyter Lab in a separate tab, expose the ports automatically, give me the running server, let me jump into it, and start working on it. So in this example, we have kind of a contrived example where we introduced a bug on purpose.
Just the first time through, we verify that the current one works through this way.
Yes.
So just be clear, the code space here is definitely running the Jupyter server.
Yes.
Even though, yeah, well, you can see from the URL, it's served from the code space, not locally, even though you ran it the same way.
Yep. Yeah, so you can see the URL. We automatically generate a random URL every time you spin up a code space. And that'll become available to you locally. So here we have a branch where we introduced a bug on purpose. And what it's going to be is the image is a little bit messed up, right? And say, I'm stuck. I don't know how to fix this. I don't know what's wrong. I need some help. I'm going to start a new branch, start working on it, see if I can figure it out.
Yeah, in this case, it was me, and I needed Cory's help. You can see from the demo. So I created a branch, made sure it ran right. Yep, it reproduces the error, all good. But I need to do something different, which is, so now that I've pushed my branch up to the repo, we can collaborate on it. The Jupyter Lab I ran in the sort of normal mode. So what I'm going to do now real quickly is kill that Jupyter Lab instance and restart it with the collaborative flag. So this is something that's actually pretty challenging to do on your local machine. So if I start Jupyter Lab up in collaborative, and then I go and on code spaces, by default, the ports are secure. They're private, so that only the person with the GitHub token that we minted at the beginning of the code space can connect to it. What I can do is I can set that to a public port, and now I can share that port with Cory, in this case, just by pasting it into our chat. And then I also need to share with Cory the token for connecting specifically to that GitLab server. So I'll just paste that to him. And then once he's there, and I go back and join the notebook too, the cool thing about collaborative server is.
Yep. Now we can both access this on a public URL. It's a temporary URL that we set up, and it's available over the internet. You could connect to it from your phone. You could connect to it from anything, and we can collaborate on this notebook together using the built-in Jupyter Lab collaborative mode, which is amazing. Thank you for building that. Whoever built that, maybe they're in the room. And now I can pair with him. We can, talk over Zoom or whatever. We find the problem. We run all the cells. We fix the bug. And voila, we can pair on a public Jupyter instance running in the cloud on an open URL with the click of, 2 buttons? That's pretty great.
Thank you for fixing my bug, Cory.
You're welcome. Typos. If anyone is like me, you always need to pair on a typo, right? So now we have it. We have it fixed. We want to open up a PR, right? So we're going to push this up to GitHub. And, we're going to look at the JSON and see everything that's wrong with it by reading JSON. If we're lucky, maybe, maybe not. Chances are it'll probably not even render. Let's check it out and see. One cool thing that you can do on GitHub that a lot of people don't know about is if you say co-authored by, you can actually have 2 contributors on a commit, which is cool. Here we can't even see the changes, but if you all go into your settings on GitHub, there is a section called feature previews, which is a way that we set up new features for people to test. We have a new rich Jupyter Notebook diffing tool that's using NBDime. We worked very hard over the last year with Vidar, who maybe is here, to get NBDime set up on GitHub. And we can actually see the wonderful diff of what changed. And if you use our new file level commenting, you can comment at the file level per diff to get some feedback into that PR.
Super cool, super cool. All right, so we got to get going here quick. So, during getting ready for this talk, one of the things that we really wanted to do was highlight the power of the amazing technologies you all have built for changing the world for good. Personally, as a cancer survivor, I really value the amazing work that researchers do of all different kinds to diagnose and treat cancer. We came across this amazing project that's hosted in ML Commons called Gandalf that we want to introduce you to real quick. Gandalf is an open source project for enabling researchers around the world to do what's called federated learning for these models, because when you take a CAT scan of someone's head, it turns out that's personally identifiable information. You can't just share those freely between institutions because that's personal information. And so cancer ML applications are necessarily very limited in their application because, as you know, ML training models determine the quality of the output of the ML. And so this technique allows distributed training of the model and then centralized aggregation or normalization of those training data sets into a common model. And they do a couple of iterations of that. And that's a pretty complex process. And Gandalf is this open source project that does that. So I want you to hear quickly from the researchers who actually do that.
Google introduced the idea of federated learning back in 2017 for improving their autocomplete typing functionality on Android phones. Of course, as you can imagine, sharing your data with a central Google server would not fly. And they introduced federated learning as an approach where you would be using your phone to train your model locally and then sharing these instead of data. But excited by this concept, my group in collaboration with Intel Labs introduced federated learning in healthcare. So current assessment of tumors is based on subjective measurements. Here we see an image of a patient of a brain tumor, exactly the same slice, exactly the same patient, exactly the same image, being duplicated and assessed by two different operators. And you see the tremendous variance of the measurements that can have. So the operator on the left, they thought that the vertical diameter is the longest one, whereas the other operator, the one on the right, they identified these two perpendicular measurements also being perhaps the largest extent of the tumor. You can see here that this paradigm is completely different between different operators.
So our group has been working on glioblastomas, which is one of the most aggressive forms of cancers in the brain for quite some time now. And we have been developing advanced machine learning and AI techniques to detect and demarcate the region of tumors, the various regions of the tumors, as well as working on other clinically relevant issues, such as predicting the recurrence of tumor after surgery. With Gandalf, what Gandalf allows us to do is basically ensure that in a reproducible manner, we are able to train models that can do all of these different tasks in a clinically relevant scenario in a much easier way. So Jupyter combined, especially combined with GitHub code spaces, allows us to do rapid prototyping of both the model design and the data configurations that we use within Gandalf, and thereby allowing researchers, both computational and clinical researchers, to generate baseline results from a completely new data set in a very quick and reliable and reproducible manner.
The models that we produced after training in all these became publicly available. They're publicly available. They're in the public domain following a commercially friendly license. So whoever wants it, they can take it, they can use it however they see fit. I think open source is a necessity in this domain. It is a very rapidly evolving field. And if we just keep things locked, we don't really facilitate the further growth. So we need this open source. Talent exists and great minds exist throughout the globe. So enabling these technologies, offering these on-demand resources to such talents is essential in order to be able to explore and go beyond what we currently have out there.
Cool, so that's the Gandalf project. They actually have a pretty unique set of needs just because they have so many different users of their system. They have the developers, and the developers, they want a Git-based workflow, they want CI, they want a quick environment setup, and familiar tools. And then they have a training step, and the training step needs very powerful machines, and to quickly be able to try different parameters and train in different ways. Then they have learners. So there's a whole group of users who are only using the models after they've been trained. And they're trying to get these things in the hands of doctors who maybe ideally are in places that don't have these high power machines that you need to run the models. But all those different types of people each experience unique needs. So we worked with them to identify what would be a good code spaces setup. And with dev containers, we were actually able to create a consistent zero config environment for all users who could spin up the right size machine for what they needed on demand with everything pre-installed that they needed to either develop or train or use the model. And we could even bring in users like doctors who don't know how to set up a development environment, and with Jupyter Notebooks, give them an interface and a pre-set up development environment so they could just start using the models and experimenting with them much more simply. And with the consistency of being able to learn in a Jupyter Notebook how to use the model, and then move to a Jupyter Notebook to do diagnosis, it really lowered the learning curve. Actually, when we moved the tutorials from where they were into a GitHub repo with a dev container, we reduced the size of the tutorial by about 2/3, because 2/3 of it was just how to set things up. Which is outrageous, right? No doctor wants to spend 2/3 of their learning time trying to figure out how to install Python. So with these abilities and Docker-based builds and all these things, you can reduce the cognitive burden and get users into a project that you would never get into a project before, and let them focus on what they actually want to do, the tasks that they're interested in. And all this is available with dev containers. If you want to learn more about containers, containers.dev is a great place to go and a resource. You can read about all the functionality there.
So today we looked at sort of 3 big phases of how you can work with Jupyter Notebooks in code spaces. So we really hope that you'll discover more resources and different kinds of notebooks across the community using the platform. Exploring and then playing with those models is really powerful if you just spin up a code space and try it out, and that makes it kind of zero setup and really quick. And then most importantly, we all create through the energy of other people and the things we learn from each other. And so the collaboration is really, to me, the most important thing. And I hope that during this week, what we'll all do together is learn from each other how we can do this even better. We've just really started on this journey with notebooks. I mean, Cory's been fighting this fight for a long time at GitHub. I've only just joined that. And the way this works is really thanks to you, the Jupyter community. So we have this little video of all the contributors to Jupyter. And we really just want to make sure that this is all about the technology that you create to enable this kind of collaboration around data. It's really quite phenomenal. None of this really would be possible without you. We have a couple of, I just want to remind people, all of this is just like zero cost to get into. So GitHub is a big supporter of open source. And one of the ways that we want to make it more accessible to more of the world, because we aren't the ones, and even those of us in the room, we're already kind of the privileged folks who know how to do this stuff and have access to the resources. We want to make it so that people who have never even thought about running a Jupyter notebook have zero inhibitors. So without a credit card, without any kind of anything, they can just get a GitHub account, go to a Jupyter notebook and run it. And for 30 hours a month of a 4-core machine for free. If you know, essentially beyond that, if you want to use it further, you can of course pay for it. We are a commercial company. And with that, I just want to leave you with the resources that we shared, and we really just hope to have a conversation throughout this week. And I want to thank you for your attention. Thank you, Cory.
Thank you very much.
Thank you very much. I believe we have the time for 1 or 2 questions before going for break. Please come down so that we can give you the mic, so that we can have it on the recording. If you have any questions for Craig and Cory, or raise your hand and we'll repeat the question. Do you have questions?
I see a question over there. Oh, a question back there.
Just come down.
Come down. We'll go over there.
Hi. Thank you, folks, for the great presentation. I'm curious, I would love to hear your comments on the relationship between some of the features that the code spaces machinery implements and what the Jupyter community has done with Binder over the last 7 or 8 years, and kind of how these are connected and how you're collaborating with the team and supporting the Binder effort, where we just had to announce the reduction of capacity from lack of resources. So it'd be interesting to hear the connection. I was surprised not to hear Binder mentioned, since it kind of did this 8 years ago. Thank you.
I very much appreciate the question. It's a really important one. And I'm going to be quite frank, I don't have a good answer for you, and I want to talk about that more this week. I joined 1 year ago, and I can always blame my predecessors, but most importantly, let's figure out how we make the right community resources available to people. I don't have a good answer for you.
Next question.
So thank you very much for amazing tools. I am an everyday GitHub user, and I have a question. Do you plan to support custom renderers? So for example, I would like to render a notebook without code. So I would like to render only output, because I believe most of the people are not developers, and I would like to share with them only the output, and it will be nice to have a URL address for each output, so I can, for example, send just a chart to other users. So do you plan to support non-technical users on GitHub?
So, all right, there's like a few things to unpack here. First is custom renderers. We do have a project that's available called Blocks. It's on a separate website, and that allows you to create custom renderers and run them.
The website is next.github.com.
Yes. So that's available today, and it can hook up to a GitHub repo, and you can write a custom renderer and do it. As far as what we would support officially on GitHub, we have extreme security policies, like extreme. And we already have to rip a lot of things out of notebooks just because of our security needs. Also, we rely on NB-convert to do all of our notebook rendering. So if this was something that was implemented into NB-convert, we could probably eventually get it in. So there's an open source path there, which I think is interesting. But as far as custom renderers, I think your best option is Blocks. Does that answer your question in a roundabout sort of way?
Yeah, so one way to think about Blocks and next.github.com is it's where sort of next generation R&D for GitHub is done, and that will eventually flow into the core product.
Yeah. Blocks.
Yes.
Yeah.
OK, I think that's it. Thanks again, Craig and Cory. Big applause.
Thank you. Thank you.
Thank you.
You should have about you can talk with them in in the hallway. You have about half an hour to stretch your legs. There are snacks scattered around the venue. I think you've seen that. After the break here, we will have community tools and practices. And in Louis Armand, which is down one level and across, we will have enterprise Jupyter infrastructure and community tools and data science. The programs are in front of the room, and we will have tutorials and hands-on session just below us in room 1, 2, and 3. If you change your mind on the tutorials, please let us know and cancel your ticket so that we can give it to other people. And well, see you around. Feel free to come talk to any volunteers or any organizer if you have any questions. And looking forward for the rest of the conference.